Now let's solve question number 25. Here you can observe we have two choices in this question. First choice is that if A is a matrix of order 3, then find A inverse. Hence solve the following system of equations which contains 2x minus 3y plus 5z equal to 11, 3x plus 2y minus 4z equal to minus 5 and x plus y minus 2z equal to minus 3. And in the second choice, it is stated to obtain the inverse of the following matrix using elementary operations, where I have this matrix A of order 3 cross 3. So very first, let's consider the first choice. Here you need to obtain A inverse. Before that, I need to check whether the inverse exists or not. Inverse will exist when this matrix is a non-singular matrix. For that, you will be obtaining determinant of this matrix. So when I obtain determinant of A, I am getting here the value of this determinant equal to minus 1. That is clearly a non-zero quantity. So it is a non-singular matrix, its inverse will exist. Next, I will be obtaining the adjoint of this matrix A. How do you get the adjoint? You can easily obtain adjoint by obtaining the transpose of a matrix formed by cofactors of this matrix A. So when I talk about finding the adjoint, here I need to take transpose of this matrix formed by cofactors of this matrix A. And on transposing it, that is by interchanging rows and column, I get here the required adjoint of this matrix A. Next, I need to obtain here A inverse. What is A inverse? That is A adjoint of A upon the determinant of A. So that gives me the required value of A inverse equal to this adjoint upon minus 1. The value of the determinant is minus 1. So minus 1, that scalar gets multiplied to each and every term, resulting this quantity as A inverse. So I get here the required adjoint of A as this matrix of order 3 cross 3 having the elements 0, 1, minus 2 in the first row, minus 2, 9 and minus 23 in the second row, minus 1, 5 and minus 13 in the third row. Now here you were provided with the three linear equations, and for these three given linear equations you need to obtain the solutions. So let's convert here this system of equations in terms of the matrix equation. I can definitely write that here I have this matrix into this matrix equal to this matrix, where I can consider this to be A. And if you recall the question, this is exactly representing the matrix A. And here I can consider this to be matrix X and this is the matrix B. Now in order to obtain the value of X, Y and Z, here I can consider that this is A into X equal to this matrix. If I pre-multiply both the sides with A inverse, then A inverse into A will result here X, Y, Z on the left hand side, and here I have A inverse into this matrix. And you already know the value of A inverse which you have calculated. Substituting that value of A inverse, and here you can observe I will be multiplying these two matrices. It is of the order 3 cross 3 and it is of the order 3 cross 1. So they are conformable for taking the product, and this simplifies and gives you a matrix of the order 3 cross 1 having the elements 1, 2 and 3 in first column. So now this shows equality of these two matrices, that is X, Y, Z is the element of this matrix X, it is equal to this matrix of the same order. So I can say that here X is 1, Y is 2 and Z is 3. This is the solution of the given system of the equations. So in this way we have obtained the required solution for this question. And in this question, when you have solved and obtained this determinant till this step, you will obtain 1 mark for obtaining the correct value of determinant. After that, for obtaining the inverse, when you obtain the adjoint, you will obtain another 1 mark. And next, when you obtain A inverse, you will obtain another 1 mark. And after that, when we consider the given system of equation and obtain this matrix equation, through this you will obtain 1 mark. And when you obtain this A inverse and multiply it with 11, minus 5 and minus 3, this matrix, to get the corresponding values of X, Y and Z, there you will obtain 1 mark for pre-multiplying A inverse and 1 mark for finally obtaining X, Y and Z. So in this way you obtain total 6 marks for this question. I hope it is clear to you. Now let's come to the second choice of this question. Obtain the inverse of the following matrix using elementary operations. Here I have this matrix A which is of the order 3 cross 3. Now here I have to use the elementary operations. For that I will be generating a matrix equation that matrix A is equal to identity matrix into the matrix A. So taking this into consideration, here I put this matrix A, and in place of I, it is an identity matrix of order 3. Let's substitute that. So here I get this matrix equation. In order to obtain inverse of A, what you need? You need to obtain an identity matrix on the left hand side. So you will be applying here the elementary operation so that you get here the identity matrix having 1 0 0 in first row, 0 1 0 in second row, and 0 0 1 in the third row. And the elementary operation which you apply on left hand side will be also applied to this identity matrix on the right hand side. So very first I consider this elementary operation where I multiply -1 to all the elements of first row. You can observe here the sign of all these elements in first row in left hand side as well as right hand side changes. After that, you can clearly observe that if I apply this elementary operation where from R2 I subtract R1 and from R3 I subtract thrice of R1. Now this will simplify first column to 1 0 0, where you can clearly observe there is no change in R1 because you have not applied any elementary operation in R1. Why we are doing this? So that we can obtain 0 0 in the first column, because you have to obtain here the identity matrix. Moreover, the same transformations and the operation is being applied to this matrix. After that, I consider R2. I take -1 into R2, then I add up here R3. So I am applying here two operations together. Firstly, I am multiplying the scalar -1 to R2, which gives me here 0 -3 -5, and adding R3 to it. That is, on adding 0 plus 0 I get 0. Then I am adding here, I have -3 plus 4 1, -5 plus 7 I have 2. Next you can clearly observe here I have -1, -2, here I have 1 and 2. If I add the second row to the first row, these two elements will become 0. So let's apply this transformation where in first row I am adding up the second row, and I also apply here this operation in R3 where I take negative of R3 and I add up 4 times R2 to it. You can clearly observe here this will become 0 and here this will become 0 0 1 when I operate this on left hand side. The similar transformation is being applied on the right hand side. After that, you can observe here you are just left with 2 in the second row. So if this 2 becomes 0, this will become an identity matrix. And how it will become 0? If I subtract twice of R3 from this. So from R2 I subtract twice of R3, which gives me an identity matrix on the left hand side, and on right hand side I have this matrix containing 1 -1 1 -8 7 -5 5 -4 and 3 into this matrix A. So here this is I equal to this matrix into A, and you know that if I have A and B two matrices where A into B is equal to I, moreover B into A is equal to I, that means B is inverse of A. So I get here inverse of A as this matrix. So here this is the required inverse which we have obtained through various elementary transformations. I hope this is clear to you. So in this question, when you have applied and generated this first equation, you will obtain 1 mark till this step. Next, when you apply this transformation, you will obtain another half marks. Next, when you come to this step, you are applying 2 operations here, you will obtain 1 marks. Next, in this step, you will obtain another 1 mark. After that, here you are applying another operation where you will obtain 1 mark, and in this step, you are getting half marks. Next, when you obtain the final inverse, you will obtain 1 mark for this question. So here, when I take the total of all these marks, 1 plus half plus 1 plus 1 plus 1 plus half, then again plus 1 gives me total 6 marks for this question, where you have obtained inverse of this matrix or the given matrix through various elementary operations. I hope it is clear. Let's proceed to our next question.